Hi, everyone, and welcome to Astronomy Daily, your daily dose of space news and astronomical discoveries. I'm Anna, and we've got an incredible lineup of stories for you today. From groundbreaking confirmations of Einstein's theories to SpaceX's latest adventure with an unusual passenger, we're covering the full spectrum of space exploration and discovery. Today, we'll journey from the largest scales of our universe, where scientists have been testing Einstein's predictions about gravity, all the way to our cosmic backyard, where China's space station has been bustling with activity. We'll also explore some fascinating new developments in space technology, including an artificial star project and a potentially life-saving emergency system for future lunar explorers. So strap in and get ready for another exciting journey through the latest developments in space science and exploration. First up today. In a remarkable validation of one of physics' most fundamental theories, scientists have just completed the most precise test ever of how gravity behaves at cosmic scales. Using observations from the Dark Energy Spectroscopic Instrument in Arizona, researchers tracked nearly 6 million galaxies and their luminous cores over a period spanning 11 billion years. That's about 80% of our universe's entire history. What they found would have made Einstein proud. The way gravity shapes our cosmos at the largest scales matches exactly what Einstein predicted in his 1915 theory of general relativity. This theory, which revolutionized our understanding of the universe by linking space, time, and gravity, continues to hold true even when tested at the most extreme cosmic scales imaginable. The study wasn't just about confirming Einstein's work, though. It was part of a broader investigation into dark energy, that mysterious force causing our universe's expansion to accelerate. Interestingly, while gravity behaves as Einstein predicted, the researchers found evidence suggesting that dark energy might be more dynamic than previously thought, potentially weakening over time rather than remaining constant. This discovery could have profound implications for our understanding of the universe's future evolution. If dark energy is indeed changing, it means the universe's expansion might not continue accelerating forever as once thought. It's worth noting that dark energy makes up about 68% of our universe's contents, while dark matter accounts for 27%, leaving just 5% for all the ordinary matter we can see and interact with, including everything from stars and planets to people and popcorn. China's space program continues to achieve impressive milestones with its Tianzhou cargo missions supporting the Tiangong Space Station. The Tianzhou 7 spacecraft recently concluded its mission with a controlled re-entry into Earth's atmosphere, with most of the vehicle disintegrating as planned and only minor debris landing in designated sea zones. Before its dramatic finale, Tianzhou 7 completed one last assignment, deploying a small educational satellite into orbit during its week-long solo mission after separating from the space station. The spacecraft had initially launched from the Wencheng Space Launch Center back in January. As one mission ended, another began, with Tianzhou 8 launching from the same spaceport and successfully docking with Tiangong's Tianhe core module after just a 3-hour flight. This marks the 15th spacecraft to connect with the station, which orbits approximately 400 kilometers above Earth. The new cargo ship delivered an impressive payload of supplies for the Shenzhou 13 astronauts who arrived at the station in October. This includes enough provisions to sustain a 3-person crew for 9 months, along with over 80 scientific packages weighing a combined 458 kilograms, supporting 36 different onboard experiments. These experiments span a fascinating range of research areas, from space life sciences and biotechnology to material science and fluid physics in microgravity. One particularly interesting study will examine how submagnetic microgravity affects fruit flies' genetic and behavioral traits, the first experiment of its kind. The crew has already begun the process of unpacking and organizing these vital supplies and research materials. Next up, in a groundbreaking development for astronomical research, George Mason University will lead a $19.5 million NASA mission to launch an artificial star into Earth's orbit. This innovative project, known as the Landau NASA Space Mission, aims to revolutionize how we calibrate telescopes and measure stellar brightness across the cosmos. The artificial star will be positioned 22,236 miles above Earth, far enough to appear as a genuine star to ground-based telescopes. Equipped with 8 precision lasers, This celestial calibration tool will enable scientists to make unprecedented improvements in measuring everything from nearby stars to distant supernova explosions in far-off galaxies. What makes this mission particularly significant is its potential impact on our understanding of the universe's expansion. While we know the universe is expanding, getting precise measurements of this expansion has been challenging. The artificial star will allow scientists to achieve a remarkable accuracy of 0.25% in measuring stellar brightness, a level of precision that has never been possible before. The satellite won't be visible to the naked eye, but will be observable through personal telescopes. It will maintain a geosynchronous orbit, keeping it positioned over the United States during its first year of operation. The mission involves collaboration between multiple institutions, including the National Institute of Standards and Technology, NASA, and several universities, with mission control based at George Mason's Fairfax campus. This infrastructure mission represents a transformative approach to solving one of astronomy's fundamental challenges: accurate stellar measurement. By providing a known reference point in the sky, it will help scientists refine our understanding of stellar evolution, identify potentially habitable exoplanets, and unlock new insights into the mysteries of dark energy. Moving on now to astronaut safety. When it comes to exploring the moon, safety is paramount, and Australian researchers have developed an innovative solution to address one of the most critical challenges faced by lunar explorers. They've created a new distress alert system specifically designed for astronauts on lunar missions, adapting the proven COSPAS SARSAT technology that's been saving lives on Earth for decades. The system represents a significant advancement for NASA's Artemis program, which aims to establish a sustained human presence on the moon. With astronauts venturing into isolated regions like the lunar South Pole, having reliable emergency communication could mean the difference between life and death, especially considering that any rescue mission could take days or even weeks to reach them. The technology relies on low-power emergency beacons that astronauts can quickly activate with minimal setup. These beacons will communicate through a planned network of lunar satellites, enabling continuous communication for up to 10 hours, even in challenging terrain like mountains and deep craters. The system is designed to be lighter and more reliable than existing solutions, with an extended battery life crucial for lunar operations. Safety from Space, the group behind this development, has received $100,000 in government funding to advance their lunar search and rescue initiatives. If successful, this Australian contribution to the Artemis program could not only safeguard future lunar explorers, but also lead to improvements in emergency communications back on Earth, particularly in remote areas where traditional communication methods are unreliable. SpaceX's latest Starship test flight drew some notable attention from military leadership, with Space Force Chief of Space Operations General Chance Saltzman making a special visit to SpaceX's Starbase facility in Boca Chica. The general spent 2 days reviewing the program and watched the launch alongside SpaceX founder Elon Musk and other dignitaries. While the Space Force hasn't made any formal commitments to using Starship, their interest is clear. The military already relies heavily on SpaceX's Falcon rockets for national security launches, and Starship's massive payload capacity could open up new possibilities for military space operations. One intriguing concept under consideration is using Starship as a rapid global transport system, potentially delivering cargo and personnel anywhere on Earth in under an hour. The launch itself marked another milestone for SpaceX, featuring an unusual passenger, a banana serving as the spacecraft's zero-gravity indicator. This 8-inch toy banana, complete with mission patches and for scale printed on its side, became the first physical payload to fly aboard Starship. One for the history books. SpaceX even decorated the massive spacecraft's exterior with 4-foot-tall stickers of pixelated cartoon bananas, playing into the mission's lighthearted theme. The test flight achieved all its main objectives, including successfully relighting Starship's engines in space, a crucial capability needed for future orbital missions. The Super Heavy booster made a soft water landing in the Gulf of Mexico, while Starship splashed down in the Indian Ocean about 65 minutes after launch, marking another step forward in the development of this revolutionary spacecraft. In an extraordinary astronomical discovery, NASA's Chandra X-ray Observatory and Hubble Space Telescope have revealed a cosmic structure that's been aptly nicknamed the Guitar-nebula. This remarkable formation features a distinctive guitar-shaped nebula with what appears to be a flame-like filament extending from its tip. At the heart of this cosmic guitar is a pulsar, a rapidly rotating neutron star left behind after the collapse of a massive star. As this stellar remnant races through space, it's creating an impressive display by ejecting a stream of particles and X-ray light that stretches an incredible 2 light-years, or roughly 12 trillion miles. The guitar shape itself forms from bubbles of particles blown out by the pulsar's steady wind as it moves through space. What makes this structure particularly fascinating is how it's producing both matter and antimatter particles, essentially reversing Einstein's famous EOMC2 equation by converting energy back into mass. Scientists have been tracking this celestial performance over 2 decades, combining observations from both telescopes to create a detailed movie of its evolution. The Chandra data shows the energetic particles spiraling along magnetic field lines, while Hubble captures the broader structure's movement through space. As the pulsar collides with denser regions of gas, the most energetic particles escape and create the remarkable X-ray filament, much like a cosmic blowtorch shooting from the tip of this celestial instrument. The discovery isn't just visually spectacular. It's helping astronomers understand how particles travel through interstellar space and providing new insights into how pulsars interact with their surrounding environment. And that's it for this episode. Thanks for joining me, Anna, on today's journey through the cosmos. From groundbreaking confirmations of Einstein's theories to guitar-shaped nebulas, there's always something fascinating happening in our universe. If you want to stay up to date with all the latest space and astronomy news, head over to our website at astronomydaily.io. There you'll find our constantly updating newsfeed, all our past podcast episodes, and you can sign up for our free daily newsletter to make sure you never miss a story. And don't forget to join our growing community on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. It's a great way to join the conversation and share your love of space with fellow astronomy enthusiasts. Until tomorrow, keep looking up and stay curious about the wonders above us.